take a look at number 10 in section 7.5. We're going to evaluate the following integral here. Of course, using the method of partial fraction decomposition. Notice we have a degree 0 numerator and a degree fifth degree polynomial down here. If we were to expand this out, right, x times this will be x to the fourth plus smaller powers of x, and so x times x to the fourth, x to the fifth. Okay, so it is in a form that we can try and break up. Notice the denominator has been factored for us. So we have one linear factor of x that gives us one possible fraction in our decomposition, a constant value over x. And then we have x squared plus 8 squared. So that's notice x squared plus 8 is prime. It's cannot be factored further over the rational numbers. So we're going to have a couple of fractions because there's two of these quadratic factors, right? First one, notice we've got a linear factor up top here, linear term that we have to figure out over x squared plus 8, and then plus another linear term over x squared plus 8 quantity squared. Okay, so what we're going to do now is we are going to multiply both sides of this equation by the least common denominator, which is x times x squared plus 8 all squared. So when I multiply this side by that, of course, I just get 11. When I multiply a by that, the x's cancel, and I'll have a times the quantity x squared plus 8 squared, which I've actually expanded above here for later. We'll use that here in a minute. And then here, 1x squared plus 8 cancels. That leaves the x and 1x squared plus 8 factor. And then finally here, when we multiply the x squared plus 8 factors, both cancel, and we're just left with x. We do have one shortcut, and that is if x is 0, we get the value of a, because if I plug in x equals 0, of course, this is 11. Notice plugging in x is 0 here and here, these just go to 0. Plugging in 0 here, I get 8 squared, which is 64. So a is 11/64. Okay. I'm going to go ahead and expand all this out. I'm going to leave in the fact that a is 11/64. As I said, I expanded x squared plus 8 quantity squared here. So distribute a, or 11/64 over those. I get 11/64 x to the fourth. 11/64 times 16 is 11/4 x squared, and 64 times 11/64 is 11. Here I'm going to expand this out so I can maybe FOIL it out and then multiply by x, right? So bx times x is bx cubed times x is bx to the fourth. Sorry, that's a 4 there. The outer is bx times 8 is 8bx times x is 8bx squared. Cx squared is the inner times x is cx cubed, and last c times 8 gives me 8c times the x. Here I just distribute the x, I get dx squared plus ex. Now I combine my like terms. I've got two x to the fourth terms, so I add their coefficients together. I just have one x cubed term. I have 1, 2, 3 x squared terms, so I take their coefficients, 11/4, 8b and d, and add those together. And then x terms, I have 8c plus e times x. And of course, my constant term 11, which better be the case, right? Because I have the constant 11 over here. So in order for 11 to be equal to this polynomial for all values of x, well, the coefficients of x to the fourth, x cubed, x squared, and x are all going to have to be 0. And so if that's the case, then b plus 11/64 is 0, meaning b is negative 11/64. And if the coefficient of x cubed is 0, then c is 0. We know the value of b from here. So 11/4 plus 8 times b, which is that, plus d, that's going to have to be 0 because it's the coefficient of x squared. And simplifying that out, I get d is negative 11/8. Remember, c was 0, so if I plug in here, I get e must also be 0 because the coefficient in front of x has to be 0. Okay, so with all of that, what has happened? We've got the original uh, thing we're integrating here, right? The original function we're integrating. Here's the partial fraction decomposition. The value of A we found to be 11/64. B is negative 11/64, but C is 0. So it's just going to be a negative 11/64 times x over x squared plus 8. The D was negative 11/8, and E was 0. So this just becomes negative 11/8 x over this quantity here. So I'm going to rewrite that. I'm going to take those, it was 11/64 over x. I'm just going to pull that out in front as a constant multiple. So it's 11/64 times 1 over x. Okay, that's the a divided by x term. And then remember the b was negative 11/64 x over x squared plus 8. And then the d was negative 11/8 x over x squared plus 8 quantity squared. So I'm just pulling those constant multiples out. Now, hopefully you know how to find the antiderivative for this first term, right? Constant multiple, the antiderivative 1 over x is the natural log of the absolute value of x. For these next two, we're going to do simple substitutions for each of these. And so the substitution I'm going to use for both of these is u is x squared plus 8. So du is 2x dx, and 1/2 du is x dx. Notice the numerator of both of them have that x dx, right? For this one, I'm just going to get, of course, I've got 11/64 here. I'm going to have du is 1/2 du integral 1 over u, which is natural log absolute value of u, where u is x squared plus 8. So it becomes natural log of x squared plus 8. Over here, notice I've got it 11/8 1/2 du, and it'll be over u squared, which is the same as u to the negative 2. The antiderivative of u to the negative 2 by the power rule is this. And so I get negative 11 over 16u, again, where u was x squared plus 8. And so if I replace u with x squared plus 8, and remembering what our first term derivative was, here's the answer we get. Notice I don't need absolute value bars around the x squared plus 8 because that quantity will always be positive. And here's the result. Again, I think Achieve wants parentheses around this in addition to the absolute value bars. So hopefully this makes sense. Okay, hope this was helpful.